Hello, my name is Mulder and this is my Capstone project, a privacy-first health monitoring platform designed for chronic care patients and their clinical consultants. In the next few minutes, I'll walk through the problem, the architecture, the guardrails, and the reliability findings. So who did we build the platform for? Our primary user will be patients managing ongoing health conditions such as diabetes and hypertension, people who may rely on daily vitals monitoring and have to share them with a consultant. Our secondary users will be the consultants of those patients who wants to keep track of the patient's health data and intervene early if possible. So our platform is also built with elderly patients who may not have good internet access in mind. So our platform ensures inclusivity by providing a offline data capture, low bandwidth UI model for non-technical patients. Moving on to our empty chair consideration. The empty chair we protected throughout the project was patients whose data could be misused. That includes risks such as inappropriate access, harmful interference, or cross-border data exposure. Because the system operates in Canada, the legal constraints are shaped by PHIPA and PIPEDA, which strictly control the consent, access, and data residency. So we are protecting these patients by following the strict guidelines provided by the law. So moving on to our architecture, here is a brief overview of each component of our system. We have a API gateway that efficiently handles request and authentication. We have a backend processing running on Lambda, so we can ensure low latency and high availability, and hopefully keep our system scalable. And then our data is stored on a Postgres database that ensures a row-level security. And then our AI module that analyzes user data and detects anomaly. And it also sends alerts via email or SMS to the patients or their healthcare providers. So this whole system should run on a serverless architecture, which should hopefully keep the cost at around $50 per month, making it quite scalable and affordable for a growing user base. Here is another view of our system diagram. You can see that our front end sends a request to the API gateway that forwards it to our Lambda functions, which then interacts with the database and allow access for our AI engine that should alert both the patients and their healthcare provider should there be an anomaly. The consent service is also a focus in our project. Should the consent be revoked, all of the data should be removed, and we will cover this further in a later slide. So, moving to our happy path replays, this is a log of what it would look like if a patient would post to /health entries with their data, Here the example, patient number 1 is posting about their blood sugar level at 5.6 mmol per liter, and then our system stores that in the database. At a future point in time, a patient or their healthcare provider could access this data by going to /patients and then user ID /entries, and our system would return the entries that the users has submitted. Moving on to guardrails and reliability. Our class control test is shown here, is included in our test/redbar file included in our Capstone project repository. So we have data residency test, where all data must remain in Canada. We are controlling this using IAM policies and S3 bucket policies that enforce regional locking, and our test should verify that. And authorized control here, we're basically making sure only assigned consultants or the patients themselves could access patient data. We're controlling this using a JWT token and role level security in our database. Our red bar test should also fail if this is violated. So moving on to observability and chaos insights. Our CloudWatch dashboards should monitor key metrics such as ingestion latency, AIQ depth, and consent revocation events, providing a real-time visibility without storing sensitive information. During chaos testing, we simulated database failover, lambda timeouts, cache eviction, confirming the system's resilience and ability to degrade gracefully under failure conditions. Incident response, so our alarms should trigger on latency spikes or error rates increases, ensuring quick detection and response to potential issues, maintaining system reliability. So comprehensive runbook covers scenarios such as database failover, AI jobs backlog, providing a step-by-step recovery procedures to ensure minimal downtime and maintain zero data loss guarantee. Moving on to cost and monetization. So our monthly cost, as mentioned, should be around $50 per month with the serverless architecture. The main cost driver should be our Postgres instance, and optimizations such as short time to live caching and S3 lifecycle policies should help keep the cost within budget. Our revenue and growth levers. Revenue model includes a free basic dashboard for patients, our premium analytics for $3 a month, and institutional license for clinics at $6 per patient per month. We could upsell this with AI-driven bundles and pay-per-prevention contracts with provinces. It should be scalable within the current serverless architecture. In terms of future growth, future growth will focus on federating with provincial EHRs and adding wearables connectors for patients. So moving on to what we should tackle next, we could implement a better deletion pipeline that automatically deletes everything given a trigger. We could also upgrade our authentication to the Cognito system provided by AWS or some other authentication management system. We could enhance observability by adding open telemetry tracing and expanding our CloudWatch dashboard to provide deeper insights into system performance and user behavior. Our current limitation is that we cap at 1,000 concurrent users per RDS instance. AI model retraining is manual and unchecked for bias, so we could automate AI training and check for bias. In the future, rate limiting fine-tuning is needed to prevent cost spikes. Deletion workflow is not yet implemented, and formal penetration testing is required before production deployment. And that is everything for our Capstone project. Thank you very much and have a good day.